is no longer magnesium. We agree with that,
Yeah.
right?
Well, they're magnesium filings,
It's
right?
way different. But if there is magnesium in there, it's coated with copper, so we can't really tell.
That's what I was gonna ask. Yeah. 'Cause they're
But
filings,
but
right?
shaking it should dislodge it. Now, of course, these are hydrogen gas bubbles because we have two reactions going on here. We've got a hydrogen displacement. All right. At the end, towards the end of our transformation of copper lab, we had an aqueous solution of hydrochloric acid that was mixed with a copper chloride solution, which has the pretty blue color. So this was towards the end. So it's aqueous, HCl, low pH, acidic, and then copper chloride aqueous. We then took magnesium because we want to get the copper out of solution and produce copper solid. So we want to reduce Cu double positive, reduce it. And we're going to reduce it using magnesium, which is going to be oxidized. So here's our magnesium solid. We put it into this solution. Notice we're going to see bubbles produced. Those bubbles produced are hydrogen gas bubbles. So we're getting actually two reactions competing here at the same time. Over time, notice the copper now has been reduced to copper metal. Notice the color has changed. We have very little copper double positive blue ions present. Notice we have spectator ions present, lots of water, and we have solid copper. So notice the magnesium was oxidized, started here, solid magnesium, and it was oxidized to magnesium double positive. The copper double positive was reduced. So we started here with copper double positive in aqueous form, and as we gained electrons from the magnesium, we ended up with copper solid. Here are the two competing reactions. All right. We've got magnesium. We put it in the solution which has both HCl and pretty blue copper chloride aqueous. Notice one of the reactions which was occurring vigorously is this hydrogen displacement reaction. We're going to yield magnesium chloride aqueous plus lots of hydrogen gas bubbles. Since a gas is being produced, we then could use PV equals nRT to determine some properties of that gas if we chose to. Now the other reaction that was occurring at the same time now, so both reactions are occurring simultaneously. We have magnesium plus the pretty blue copper chloride solution. And we're producing magnesium chloride aqueous, so we're going to have a change in color, more or less colorless. And now we're going to have copper metal, which will be brownish. And here it is from afar. So both reactions are occurring. The magnesium goes into the HCl and the copper chloride aqueous. Both are occurring. Notice we're getting copper solid produced. That's the point of this lab. But we're also seeing these bubbles, which are hydrogen gas bubbles. And notice we have the spectator ions now. The spectator ion is going to be Cl minus actually. And the Mg double positive is not a spectator ion. That's actually that's one of the products of the reaction. Maybe we'll step back, get the big picture here. Here we go. Two competing reactions. And again, notice, since we're studying gas laws, notice we could determine the moles of the H2 gas and then plug that into PV equals nRT and determine maybe the volume that this gas would occupy under certain conditions of temperature and pressure. Now here is a look at the reaction as it's actually happening.